All right, let's look at the membership statistics. The total membership number for as of today is 4,480 people. It's really great to be able to see that the organization is growing, that people are continuously talking about the industry, seeing how the industry is developing and changing, and then forming part of an association and a body that can actually assist and be a place of mutual learning. So it's really good to see the association growing steadily all the time. You'll see the numbers for the company and the founding members as well on the screen. You should be able to see that. And then happy to report that we have had 445 people take a P4 accreditation test in 2024. We think that's wonderful. We think it's great that the industry is continuously upskilling itself. So these are not just new practitioners. These are it's a mixture of new people, but also of practitioners that's been in the industry for years that keeps doing their accreditations and keeping it updated. I see there's a message from Marlize that says the sound is not coming through. I hope it is now. Can someone give me an indication of whether you can hear me?
Yes, we can hear you.
Okay, great. So just to get back to the P4 platform, the P4 platform tests are updated every year. We are actually right now in the middle of that process with our P4 SteerCom. So the SteerCom at AREP is made up of lots of training institutions that do solar PV training, and these people volunteer their time to participate in us updating the questions, updating the tests, making sure that what we're asking is relevant, that we're including new information that's become available. So this number, this 445 people that have committed to doing their accreditations, is committing to staying updated to relevant information. So I want to thank you for that, for all of you that have been diligently doing your accreditations, making sure that you can provide the best possible service to South Africa is wonderful. So thank you for that. Then Anne is unfortunately, those of you who know Anne, she is our account manager at AREP, and she's unfortunately not able to be here this morning, but she did ask me to just remind you that you can register your company with AREP if you are interested in doing that. We have two options. You can be a company member or you can be a founding member. So company members and founding members have two different sets of benefits. When you register with the association, there's a little bit of marketing involved. So you get a little bit of exposure on AREP's behalf. But I think the biggest benefit is being able to say that my organization has joined an industry body association. We have submitted to the Constitution and the Code of Conduct. Here is our membership certificate. You can, if you have a if you are a little bit, if you as a client have an issue, you can contact my association. So it's for clients is usually a good safety net to be able to say that my practitioner and my service provider is a part of a body like AREP. So if you are interested, please reach out to Anne. I'm going to put her email address in the chat over here. And then you can just send her an email. You're also welcome to contact me, but Anne is the one that works directly with the memberships. Okay, let's take a look at some industry news. We as an association realized that there is a significant risk based on the lack of fire prevention standards as it relates to solar PV in South Africa. We don't really have any set standards relating to fire prevention in South Africa, specifically for solar PV. And we have called a meeting between various stakeholders. It is currently scheduled for the 3rd of September. And we aim to open the floor and get all of these brilliant people to sit together and create a document that will hopefully be adopted across industry by all of the stakeholders to say this is what we think should be fire prevention standards for the solar PV industry. So that's a very interesting project. It's probably going to be a little bit more on the long-term side because we do have to get all of the stakeholders to buy into the idea, firstly, and secondly, to agree on what the standard should be. So as you can imagine, that is quite the negotiation that would be that's in front of us. But we are very grateful that all of the parties have agreed to participate and are quite positive about the development. So if you want to keep us in your thoughts for the 3rd of September, we will be having this the first of the many discussions, hopefully, on setting up fire prevention standards for the solar PV industry. A second bit of news I am excited to share is that AREP has partnered with IPA to produce a formal policy and complaints resolution process for the industry ombudsman function. So we are very excited to learn from IPA's experience. We are excited to see the resources and manpower that they will be bringing to the table once we get the process for the formal complaints process sorted out. We are currently working on that, and then after we have this all in place and their team is able to take on some of the workload, I'm really excited to see how the industry ombudsman is going to be making a significant difference. Right now, I'm looking at the workload that is at the IOSO office, and it's over 600 complaints, active conversations. So it's a lot. There's a lot happening. There's a lot of people that need help. It really did, opening this office really did make, did touch on some sensitive points in the industry. And it's been great to see how people are using the available service. It's been a little bit of a frustration not to be able to help people more efficiently and quickly. But we are excited to now have partners in IPA and seeing where this will go and how this will play out. If you have any suggestions, or if you want to be involved in the ombudsman function, you are also welcome to just contact me or Anne. We'd love to hear from you. If you hear anything in these meetings that you would like to be involved in, or that you want more information on, please reach out to Anne or myself. We will be happy to have a conversation with you. Then I wanted to let you know, just formally, in case you did not know, that Jocelyn Hill is AREP's research and surveys member liaison. So she's our official contact person, and she is responsible for executing a lot of the research that we do at AREP, industry research. So to give you some context about the research, we do surveys and we ask a lot of questions from our members because we want to have information that we can draw conclusions from and have viable data that we can use when we are meeting with different stakeholders in the industry. So it's always helpful for us to know as much as possible about our members and about your reality in the field every day. So I know that Jocelyn has mentioned that a few of our members get a little bit frustrated when they hear it's Jocelyn asking survey questions again. But I think the vast majority is in general positive about it, because I think the underlying motivation is always to create something in service of the industry. So that's just so you know, we don't sell these surveys, and we don't do it for fun. We do it because we need to understand the industry better so that we can help problem solve a lot better. But I do want to caution that Jocelyn is the only person from AREP that you will ever have to do a survey with. We do not have anyone else employed for that function. So if you receive a call and this person's name is not Jocelyn, then you would know it is they're not from us. In terms of survey and research now, it's not Anne or myself, or Carl might also phone you. But if it's a research and they're asking financial questions and it seems a little bit dodgy, then it's not us. We did have some reports from this number on the screen phoning people saying that they are from AREP and they were asking lots of very personal financial questions. And luckily the member did report that to us. So now we know that this number is some telemarketer. So please just be aware of that. Just make sure that you are talking to Jocelyn when you are giving industry-related information in a survey request. Then we have been made aware of some extensive phishing activities in the industry. So a lot of the distributors, many of our big distributors has mentioned that this has been a problem for years, but it is escalating on the electronic front. So phishing in the context of what the distributors describe to us is now used to kind of establish what stock you have available. If you are in any way or form selling products and not just services, then what happens is you would receive an email looking very much like this, asking about your, asking for your stock, and they want to place an order. And once they have the information, then the scammers or the thieves would then know exactly what stock you have available, and obviously where you are located. A lot of the times these guys would in a point in the conversation after you've received an email like this and you've engaged with them, and if you've let them know, yes, I have this equipment, but I'm only getting my stock on Thursday, something like that, then they would know exactly where you are, what stock you have, and when you're getting it. And then, unfortunately, that would be very, very efficient for them in then stealing all of that. So that has happened in the past. And so we wanted to make you aware of what a phishing email looks like. Just the things to be aware of. What you can do, there's another example over here. What you can do is you can immediately look at the email address where it came from. Just be a little bit suspect when people are just reaching out with an offer that just sounds too good to be true. It usually is, isn't it? So look at the email address before you respond. Google them, see if these people have a legitimate website, if they have some Google reviews, if this looks like a legitimate company. It's the little logos that they use, even here at the bottom of the screen, you can see there's an attachment with a legitimate looking PDF form. So everything looks very kosher. But if you look at the email address where it originated from, that's not a real government address. It has the letters gov in it, but it would have to be .gov for it to be anything remotely official. So we wanted to just remind you of this, to just be aware that there is phishing happening, that people are trying to establish what stock is available where. And if you come across this, please let us know. Please send us examples of anything that you come across of. We would love to know that. We would love to be able to report these guys and make sure that none of our members fall prey to their schemes. So that's all of the information news related that I have. I do want to remind you that if you want to stay informed with what AREP is doing on a little bit of a more day-to-day basis, you can join the AREP WhatsApp group. There's a QR code on the screen. You can just join us by scanning that QR code of your phone. We are much more active on LinkedIn than we are on Facebook, but we do have a Facebook page if you have any questions. Usually the best way to get a hold of us is not actually through social media. You can just contact Anne or myself directly, or even Jocelyn. We're much more contactable through email or WhatsApp than we are on Facebook and LinkedIn, actually. We do also have a YouTube channel where you can watch all of the recordings of meetings, of webinars, a bunch of free information available for you there. And then just the promotion as a small thank you for joining the meeting. I have mentioned the P4 Level 3 assessment that has been launched a while ago. So if you're not familiar with the P4 Level 3, it is a practical element that we added to the P4 quality assurance program. Level 1 and Level 2 is online tests. And level 3 is a practical element. We use the AREP hybrid test report to come out to your installation, one of your installations. Then an accredited practitioner will assess your installation based on the hybrid test report. So we use the simple test report that you can use yourself and that you can give to your clients when you've finished an installation. We use that report. We just check it with you. And then you and the other practitioner have a discussion about, hey, why did you use this wiring here, and why did you put this there? And you can both actually exchange information. It's a good way for the industry to regulate itself It's a good way for you to learn, for you to connect to other people doing the same thing that you are doing. And it's also a good way for you to earn additional income, because every time you go out and you do an assessment for a practitioner that wants to get accredited, we pay you a fee of 2,000 Rand. So if you see here in the promotion we're currently running is a 50% off promotion. If you want to usually get P4 level 3 accredited, it would cost you 3,500 Rand. And then for the first accreditation and everyone thereafter that you go out and do, we pay you 2,000 Rand. So right now we are only going to be asking 1,500 Rand for accreditations, which means you're going to give that fee and we're going to make up the rest to get to 2,000. We're going to pay the person coming out to your assessment $2,000 to come and look and have a conversation. And then the next time there's an application, hopefully that will be you. We are sending out to go and do an accreditation so that you can earn additional income. It's a wonderful program. If you have any questions about it, please let me know. I'm happy to talk you through it. I'm happy to answer anything that that you have, any concerns that you have. I'll also, once Marlize is talking now, which is the next point, I will paste the P4 level 3 summary in the chat just for you to have a look at it and just a little bit more information on how the program works. All right, that was 20 minutes of me speaking. So I am happy to introduce Marlize, I think, Marlize, from ESKOM, who is the Corporate Specialist Fire Protection Generation Engineering at ESKOM. What an well-rounded, absolutely intelligent, experienced individual this is going. I was so impressed with her knowledge and her passion for what she does when we had a meeting earlier in last month. So I'm very excited to introduce her. Thank you for making time for us. Please enlighten us with your knowledge and experience.
Thanks so much. Just to confirm, you can hear me. Sorry, I had some sound glitches before when we started.
Yes, we can.
Okay, I'm sharing my screen. Share. You can confirm for me when that's showing, please.
It's perfect. We can see it.
Okay, so thank you so much for the opportunity and that introduction. Apologies, like I said, I had some sound issues in the beginning. As was said, my name is Marlize André, not Marlize, and I look after fire systems within ESKOM. Have been there for a while. It's been 20 years plus now, so have seen a few things in lots of industrial aspects. And yes, I was approached by AREP in terms of looking at fire systems with regards to not only solar PV but more BESS systems, and we have been involved in some of that. So I've just put together a few slides specifically for today, where we will not only talk about the BESS and some of the experience that we've had and what we do, but as well as the solar PV. So just in terms of quickly, because there are lots of these systems in ESKOM. So yeah, so happy to share. Let's get started. So I've moved my slide to the second one now. Just confirm for me, please, if you can see it. It's just a content slide. I'm going to just quickly. Perfect. Can you see? Great. Sorry, I'm just worried about the bandwidth here. I'm on site, and I hope everything goes smoothly with the connection. So what I want to share today with the team is just to quickly touch on fire engineering in terms of what I do and how it's perceived as such, but then also talking about solar PV and some fire considerations, just 2 slides in terms of some aspects there, what ESKOM's experience has been with regards to the battery energy storage systems that we have, and then in some concluding remarks with regards to what we need to make sure we look at when we look at fire for these type of systems. So The next slide I'm sharing now talks about fire engineering. So the definition that I've copied here for you is specifically coming from IFEs, the Institution of Fire Engineers. And the reason I always like to share this is generally in my field, the guys like to build something, and then afterwards they come to me and say, "Hey, Marlize, what fire protection or fire detection must be put on this conveyor," or whatever the case may be. And it's very important to understand, not only for the broader audience, but in general, the engineering discipline, is that fire engineering starts not at bullet 4 here, which talks about the design and installation of fire detection and fire suppression systems, but it's actually practiced through several ways. And where we start is assessing the hazards and risks of fire and its effects. So whatever we're busy with, whether we're building a PV plant, whether we're building a power station, coal-fired, the hydros that we have very many of the different types of systems. We need to understand and assess those hazards and risks associated with that specific piece of equipment or plant or system that we are putting on the floor. And the first thing that I need to look at, and that's the approach that we need to follow, is to mitigate the potential of fire damage by proper design. And I'm not talking about the design of the fire system. We're talking about the design of the turbine, the conveyor, the PV plant, the base system, construction of that, arrangement of that, building materials, etc., transportation of that system. So this is things that happens way before we talk about a fire protection and a fire detection system. And then the third bullet there, assessing the level and evaluating the optimal preventative and protective measures that we need to do to limit the consequences of a fire. So that's where I want to play today in terms of the field, and not talking about protection and detection systems necessarily, but how we work through this process to get to acceptable level of fire risk in the systems that we provide. So the next two slides that I'm going to go through talks a little bit about solar-specific fire prevention considerations. ESKOM has also dabbled a bit in CSP, so the concentrated solar plants, which is, I always think about the movies and the salt tower in the middle and all the PV panels standing around it. But yeah, so that type of arrangement. But I'm going to just talk more about the photovoltaic, specifically PV, in terms of the audience and what you guys know. And please, I'm mechanical, so sometimes my electrical terminology is not entirely correct. Forgive me for that, but we need to ensure we all are on the same page and do what we need to do. So solar specific fire prevention, design and equipment arrangement, very important aspect to consider when we think about fire prevention. Hazard protection, whatever hazards we define, how are we going to protect it? But what I wanted to highlight here for PV specifically is talking electrical fires, which relates to failed PV modules or strings and cabling. Hydraulic fires that you could see when you typically have the hydraulic oil systems for multi-plane tracker positioning systems of the PV modules. That's definitely an additional risk that is there if you have these plane tracking systems. Inverters, switchgear, cable fires, transformer failures, but then also the external risk, which we should not forget, where we position these things. What is the exposure type of fires that is around our plant or our system that we're putting on the floor that could expose our system. So typical risk considerations that we must look for in terms of PV. So looking at the next slide there, which now talks about PV plant fire causes. So this is an insurance report, and this is worldwide, that we looked at in terms of PV plant fires and what typically causes PV plant fires. And as you can see here, I'm just going to highlight a little bit on the bolded aspects there. Product flaws, something that is a specific cause of PV plant fires is when you use products that has flaws. Planning errors, very much a prevalent direct cause of fires, where mechanical and electrical design errors is made with regards to the system that we're installing. Because what we must always understand, we are stringing a bunch of equipment together to provide a system. And from the mechanical side, some of those areas have been related to the causes of PV plant fires, but electrical side, much more prevalent, obviously, because of the PV aspect, unsuitable inverters, undersizing of cables, undersizing of DC main switches, wrong type of fuses, etc., which have been causes of fires. The third main bullet there talks about installation defects. And I think we all are aware of the risk that we sit with if we have incompetent people or people that is not sufficiently trained to install these systems, make sure everything is connected properly, etc., etc. So installation defects, I think, is a worldwide aspect. And then external factors, as I've said in the previous one as well, which has also been causes of fires in PV plants. So other than veld fires, something like lightning and animals or rodent issues is also things that must be considered and has actually caused PV fires. So that's the 2 slides on PV. I'm going to move into BESS applications now, and just to understand ESKOM's main, or my playing field with BESS now has been much more on the in front of the meter side of the battery energy storage systems, where we have put a few plants on the floor ready, and we're in the process of building some, and some are in contracting phase at this stage, but mainly in the Eastern, Western, and Northern Cape areas. There are 2 plants in KZN as well, where we're ranging size-wise from 5 to 80 megawatt slash 30 to 320 megawatt hour. So industrial scale type of installations. And use case, some of them are used for ancillary services, load shaving, renewable energy shifting. So they've been placed strategically in the grid. It's owned, these assets is owned by our distribution colleagues, or I work for generation, but my distribution colleagues. So we've been assisting them with regards to looking at the fire risks that you're sitting with here. And the biggest aspect that has come up, obviously, is the lithium ion batteries that is typically the base system, and the risks that you sit with specifically with lithium ion batteries. So this slide, I just wanted to just give you an idea in terms of, so typically when we look at base systems, and you look specifically at the battery risk now. So looking at that, you have a cell. Cells are basically put together to form modules. These modules are built together in racks, and then these racks are then basically stringed and forms then your battery energy storage system that we've been utilizing as part of our base systems. So understanding now here that when a battery failure happens, typically that's single cell fails. And we're going to touch on this thermal runaway now. That's the phenomenon that we see in specifically the battery or electrochemical type of electrical energy storage systems. Electrochemical energy storage systems. So that fire then cascades through the module. The module typically then basically goes from the fire cascades then further from module to module, and then understanding how these racks are then affecting the racks next to them. So this is something that we must understand, how the fire behaves, to understand how we're going to, what factors, what things, what barriers are we going to build in place to ensure that this doesn't happen. The triangle here that I want to show, this is normally in our fire talks, this is normal. We all know the fire triangle. You need heat, you need oxygen, you need fuel. And this is what gives us a fire. The problem that we have with thermal runaway, which is the term being used with the batteries, is that when thermal runaway starts occurring, you actually don't need oxygen. You can, so our normal way of actually extinguishing a fire, where we smother the fire and we take away the oxygen, it actually doesn't work on a thermal runaway fire. So you need to be very, very careful, and understanding then thermal runaway is basically this electrochemical cell that just through self-heating, due to a flaw, due to it being overcharged, due to whatever reason, it starts basically self-heating in an uncontrollable fashion, and it just generates heat at a higher rate that it can dissipate it. And then this not only leads to fire and explosion, but also off-gassing. So understanding as well that when these batteries burn, they actually give off a toxic gas. So looking at this and understanding, then there's a database that keeps track of battery energy storage system fires. It's being kept by EPRI, the energy, I forget the acronym now, but EPRI, it's a research association in America. And these fires has happened all over the world, Asia, Europe, America, in terms of size-wise, from small commercial typical applications up to utility scale applications. The problem is in terms of the installation, some of these things was actually being, before it has been installed, before it actually has been commissioned, some of these batteries start burning, or when there's a flaw in the battery, the fire starts when they're transporting the batteries to the site. So there's been some incidents on ships, on the cargo ships that bring in the batteries if it's being brought overseas. So there has been various incidents at various stages of installation and age of system, from 0 to 67 years after the system has been installed, where some of these incidents happen. So there has been a lot of focus on this to try and understand how we can do things better so that it doesn't happen. So after doing this research and what we have found, when we look at battery installations, you have to start at the component. We have to ensure that all of the components that we have as part of our system is actually being manufactured, being supplied, being built in accordance with some kind of governance codes, standards. It's being tested, etc., etc. So it's very important to look at the system component quality, so the different systems that we are putting together. The aspect of the energy storage system, so very important, because now we are stringing stuff together, an inverter, a battery, or whatever is part of that system. And you have to understand at the design of that, the integration of that, and that you still have a safe system with the different components linked together. This energy storage system is always linked to a bigger application, and we need to also see how the energy storage system is then, according to the standards, what is the things that we must look at to ensure that the system within the installation is also safe. The building or the battery management systems, the control systems, those type of things are doing what it's supposed to do, have been tested, have been stress tested, and all of those type of things. And then we are obviously linking it into a bigger environment, in terms of feeding power into the grid, or whatever the case may be. So fire, actually, we had to start from this level to understand that we do at the end try and give a proper system. I had to add this slide. One of our main standards that we looked at for energy storage system fire prevention was looking at NFPA, the National Fire Protection Association 855, and some of the things that they're asked that you need to look at and that you need to consider when you are building these systems are they indoor or are they outdoor? Very important, especially in terms of the size of the system. And in actual fact, we can't do too big a size indoor because of the risk, because of that off gas, because of the explosion risk. You need to be very careful where you position whatever you're building. When you are outdoor and you are remote, or whether you are near other exposures, so very important. So on a rooftop, open parking garages, the standard actually give guidance depending on where your system is, what is the things that you need to look at. Indoor, outdoor, very specific size of the system, elevation, do you have fixed fire protection, then is there water supply, is the area where you're placing it occupied, etc., etc. So I wanted just to highlight there are various considerations that you need to look at when you build these systems. And then also, obviously, very important is your battery technology. But I had to add this. I know it's very small, but I just extracted the table from NFPA 850, and I get lots of guys who tells me, yeah, but my battery is a lead acid battery, so we don't have thermal runaway. That's an actual fact not true. So there is still a possibility for thermal runaway, whether you have lead acid, nickel, lithium ion, it is the worst, and the point at which thermal runaway starts is the quickest. But the principle is it's not dependent, or it's not specific only to a specific battery chemistry, and understanding that there's specific things that we need to consider depending on the actual chemistry of battery that we're using. So we can't just switch and swap things out and suddenly use another product and not have considered those things when we now, in terms of a different technology type, a different component that we're going to use. So this slide, just to show what philosophy we used. I'm not going to go into too much detail here, but a cell certification with regards to UL 1973 was very much used. It's a beautiful standard. They do drop tests and overcharge tests and do all funny, funky things to make sure that this product that you're getting is a proper product. So when you get a product that has a certification of UL 1973, you know the product has been manufactured and it's checked properly and all of those things. You know you're getting a quality product. The additional thing that we were looking at was UL 9540A, where they actually force a cell into thermal runaway, and they look at the fire propagation hazard and also the off gas. So the gas that comes off of that battery when it burns, because it depends on the chemistry. Is it toxic? How toxic? What's the explosion considerations that we must take into consideration when you design the system? Reason being here, because we've actually killed firefighters across the world, where these battery energy storage systems within the containers start with thermal runaway, they open that container, and then there's an explosion. So this has happened, and it's something that the guys are very much have to look at and understand. So you test the cell. If the cell doesn't pass, you can test the module. If the module doesn't pass, you can test the rack, just to look at how that fire propagation happens. What is the off gas? So what type of HVAC? So it's a deflagration protection. That explosion protection must be designed into the system so that we have a safe unit. And then looking at the whole system, NFPA 855, as I've mentioned, but also not forgetting, if everything goes wrong now and we do have a fire, what is our alarm response procedures? What is our emergency response procedures? Who is going to come to fight the fire? Who's going to be the first guy there? What can they do? What should they not do? Understanding if we're putting this in a community area where there's a farming community who then breathes in these toxic gases and they can die, obviously they must be very well aware of what they should and shouldn't do in an event of a failure and a fire, because all of these mechanisms that we put in place can fail, and then we do have a fire. So this is just a bit of an approach that we followed while we were looking at our systems. Other considerations: municipal fire brigade. If we are putting in a large system somewhere, does the local fire brigade that's going to respond know what risk we put down there? What hazard they're going to walk into when they want to come and fight a fire there, and are they aware of everything? So important that they are aware and they respond appropriately, so that we don't kill them in the process if they do respond. Transportation, I've touched on that. How do we get our batteries to site? How do we handle and safely package these things? Because there has been incidents with batteries burning as we transport them to the various places where we're actually going to install them. Fire system alarm.
You're not going?
Sorry. Fire system alarm response time. That's fine. Very important, because if you are building a system like this in a area that is completely remote, and the closest municipal fire brigade that's going to respond is 3 hours away, we must really consider what type of fire alarms we're going to put in. Where is the alarm going to go to? Because we will much rather have the system being designed in such a way that we don't burn down the whole site before anybody actually gets there. So understanding who we're responding to, or who the alarm goes to, and how long it's going to take them to get there. Insurance, this is always a very important aspect that we miss. Whoever is insuring whatever asset we are attaching this PV/base to, what is the insurer requirement? Are we putting down a plant that is insurable? what are the critical factors that we need to consider when we look at what we're putting on the floor, and can insurance actually insure it, and do we follow due process with regards to that. And also decommissioning and recycling, understanding that our biggest plant that we're putting down has 116 containers full of racked batteries. So when we start to decommission in these systems, where are we going to take these batteries to? Because actually recycling plants are sitting with the same issue of thermal runaway happening at the recycling plants. And it's something that we have to consider and think of. So in conclusion, what I wanted to bring home and just think about or put on the table is that in order to have a safe design, we need to look at fire risk control measures that actually minimizes the risk of fire initiation. We do not want the fire to start in the first place. And the best way of doing that is by ensuring we have governance, we have standards, we have certifications to give us quality products, that those quality products has been actually integrated in a quality manner. The systems work together. We don't just suddenly swap out one product for another product because we couldn't get the other one. And we don't look at the integrated system, whether it fits into our existing design appropriately, like then cables are not sized right or whatever the case may be. And then quality of installation. Who is installing this? Are they certified? Will they do the right thing? Because if someone picks up a battery and they by accident drop it, do they understand that now they could have caused that a fault in a battery that can cause thermal runaway? So all of this relates to quality of integrated systems, and quality of installation. The next part of it, we can put the most beautiful system down on the floor. If we don't inspect, test, and maintain that system by competent people with the right working procedures, the possibility of a fire is there because, yes, it's just like that with age. We need to ensure we provide the correct inspection, testing, and maintenance at the right frequencies. And then those external exposures, always very important, especially if we have systems that is located remotely. Vegetation control is so important. We don't want a felt fire to actually affect the system that we've put down. Housekeeping, not storing things that we're not supposed to put in places. That's something that I'm very passionate about, because with housekeeping, that's a very simple thing to do to actually prevent a fire from starting. So this is the area that I want to focus on and make sure we don't have that. But then if we do have a fire that starts, we need to be very sure that the fire protection, detection, and manual equipment that we have put in place is appropriate, will do the job, and is actually fit for purpose. So important to understand what hazard and risk we're dealing with, and what protection detection we are putting on the floor with the manual stuff as well. Do your customer know what they need to do in case of an emergency? So very important that we don't, because fine, we can burn down the guy's house, but at least just don't kill him. So they need to know what they can and cannot do when there's a fire. As well as then obviously the local fire brigade, if they do respond, to understand what risks we've put into that area and how they can respond and what they should and shouldn't do to ensure that when they do fight the fire, they are safe and do what they need to do and do it correctly. Okay, so that's me. Thank you very much. Thanks for the opportunity.
That was very interesting. Thank you so much, Marlize. That was very worth listening to. I want to open the floor now for any questions that we might have. Do you have any questions specifically related to an installation that you might have done, in general, fire, anything that you think that Marlize might have some insight on? You are so welcome to post your questions in the meeting chat. And then we will take the next 12 minutes, whatever is left of the meeting, to answer those questions. So Sean says, what fire extinguishers should or shouldn't we use on lithium batteries?
Okay, so typically it doesn't matter what fire extinguisher you're going to use. Typically any electrical type of equipment, we want CO2. CO2 fire extinguishers is the best one to utilize. But unfortunately, even if you actually empty a CO2 fire extinguisher on a battery that's in thermal runaway, it will still continue afterwards. The burning will still continue. I've seen tests that we've done. They actually force a battery into thermal runaway. You empty a CO2 fire extinguisher on it. When you take it off, it just continues burning. So typically, if you look at any type of fire extinguisher, CO2 is used at electrical equipment. DCP, the dry chemical powder extinguishers, can also be utilized, but then you have a residue. Obviously, when you've used that, it's a fine powder that then is over all of the electrical equipment. So typically, if you have that residue, if you don't clean it off in time, it actually you can throw away the equipment you've used it on. So it's just important to understand that aspect. I've seen in the market, guys are coming out with fire extinguishers specifically for lithium ion batteries. What they fill it with is some kind of a vermiculite type of aspect that they say that actually moves into the battery, the chemicals. So I've seen that. I don't know how much those cost, but you do get guys that claim that they have fire extinguishers with a liquid inside that can cover lithium ion batteries. Just be careful. Make sure if you do go for anything like that, that you have a certification, you have a test report. If you promote something like that, that you don't promote it for just because the guy says so, but that you have proof to back it up. So that would be my advice. That's generally what I do. CO2 can be used, but it won't extinguish it. It will keep going if it's thermal runaway. So there's just no answer that will help you there. But just whatever you do use, make sure you have that certification. Okay, I've got other questions now. Sorry, I'm scrolling down in this thing. Question: fire extinguisher. I hope you are fine. Sean, is that fine? Have I answered you? Any information, the rapid shutdown or regulation of rooftop solar? Any further information about rapid shutdown regulations for rooftop solar? Yes. Ralph, I know we must just be careful. There's some design where you have like an emergency button that that can isolate the system. Generally, what I know, firefighters, if that solar system, if your PV panels have started burning, the fire guys won't actually fight the fire because of the risk of electrocution, because the PV panels can't be shut off. So there are as part of the design, you can have an isolation switch, but then obviously your customer and the fire guys must be very well aware where that switch is. I don't know if that answers your question. That's what I know of that specific aspect. Nicholas, do I know where faulty or burnt batteries should be disposed of? We need to take it to battery recycling. Remember, that's why we collect batteries. It goes to wherever those recycled batteries goes to. We need to make sure it goes to the relevant battery recycling plants, not throw it in the trash, because that's generally where we have fires on normal dumps, which is very, very toxic and not great. So I can't give you a specific place, but I know obviously everywhere where Woolies and whoever who collects electronics and batteries, there's specific recycling plants for batteries specifically where we need to send it to.
Can I just interject there?
Maybe, yeah, please.
We had a very, very interesting conversation with Circular Energy this morning, which is a PRO company related to the EPR fees. I don't know, it's a lot of acronyms. I'm not going to explain all of them right now. But the point is they have a free collection system where you can log a request to collect your end-of-life solar panels, all electronic equipment. I'm going to post the link in the chat if anyone is interested. We will have them on the members meeting as well. We have invited them to do a talk. But yeah, good news. There is a place that you could just simply log a request to come pick up the equipment.
Well, that's great. I would also love that info. Thank you. Okay, so Mohammed, your question, what's your take on the fireball extinguisher? Guys, I've got the fireball extinguisher. I've got a research paper from Stellenbosch, who has a brilliant fire engineering division, first in our country. Professor Richard Walls, who is there, is doing great things for fire engineering in South Africa because the discipline is not very well supported, governed, or whatever all of the above. But basically, I've got a research paper that I can also share from them, and they've indicated that fireball is can only be used in very specific circumstances, and the main thing is you have to have an enclosure, so it must be a tightly enclosed area, because basically that fireball is a DCP bomb. If you the dry chemical powder that's typically in a fire extinguisher, so that DCP powder is basically inside that ball, and when it explodes, it basically just throws all of the DCP powder in whatever direction the explosion takes it. So not a good thing for wide open spaces. They've tested it. And I can share that paper. So it's not me. I try to make sure we work on tested, approved things, and the fireball, in terms of what I've seen, is not a great solution for base systems specifically. I lost my place now. I don't know which question is next. Fireball. Okay, Ralph. What guidelines and regulations are in place to reduce battery fires in residential applications, EI fire doors ventilation? So this is very good question, and typically it depends on where we install them. Remember, if you have it in the garage with regards to where the battery is and all of that, that's typically the place where it should be, in my view, because house designs are very specific to have a firewall between your garage and your house. So you have a 2-hour rated firewall that separates your garage from your house. So that typically should be fine. But if you start positioning this battery in someone's living room next to the curtains and things like that, you're exposing them, and this is what we need to be very careful of. There is no guidelines that I know of, and we can check NFPA 855. Like I said, I checked it now for large industrial scale aspects, but obviously they will have some guidance with regards to indoor and size. That gives us some guidance, but I think that's also why we need some kind of a guidance for specifically when we do these installations for houses. Ralph, I don't know if that helps you. The ventilation aspect, look, in the garage, it should be fine. But if we start putting it into other rooms in residential or even commercial, when we built these base systems, my fear was always some guy like yourselves, in terms of an installer, not maybe understanding or knowing what risks you're sitting with fire with regards to the lithium ion batteries specifically, and we building things like this in basements, in confined space areas, large scale, more for commercial buildings, and things like that, and us not taking care of the ventilation aspect there. So not residential, more for commercial and malls and office blocks and things like that, where we must be very, very careful about positioning and ventilation and fire doors then, because as you said, if it's an enclosed area, the 2-hour rated requirement is typically there, with fire doors separating that area completely from whatever else is situated in the building. I'm going to go further there. Request to collect damage in the electrical life solar equipment. We've done that. I've been listening. I've noted that we're no longer dealing with normal electrical installations. My understanding now, BESS fall under hazardous locations. Your BESS substation is classified as zone what? Temba. So yes, typically batteries. So when you look at hazardous locations, we're talking SANS 10108, which is the SANS that classifies a battery room typically in what hazard you have. And it all has to do with the off gas. So typically, or not the off gas, the charging. When you charge the battery, if it does give off hydrogen. So it's to do with your type of battery, number one, and then hazardous zone classifications is then classified accordingly. Some of these containers that's out in the market is very nice because it's not a walk-in unit. You actually access everything from the outside. So that helps a little bit with the zoning, so that your light fittings and your fire detection and all of the other electronic equipment that you have there doesn't necessarily have to be HAZLOC rated. But yes, it is something that you must obviously consider when you have large scale. Is it hazardous location based on what you have? And then is typically, I would expect it to be zone 1 or 2, not zone 0. And then all your other electrical equipment will have to be EX rated in relation to your zoning according to SANS 10108. Thanks, Tembo. I don't see any other questions at this stage.
Perfect. Thank you. I see it is 12 o'clock. If you do think of a question that you have, you're welcome to email me, then I can get in touch with Marlize. Thank you, everyone. It was a good meeting. I think we all learned a lot. Yeah, I will post this meeting recording on the YouTube channel soon, a little bit later today, if you want to go and rewatch and look at some of the information. Thanks again, Marlize, and thank you everyone for attending. Have a wonderful Thursday.